such that u is equal to phi1 of x comma y and v is equal to phi2 of x comma y. Then we define the determinant. The determinant partial derivative of u with respect to x, partial derivative of u with respect to y, partial derivative of v with respect to x, partial derivative of v with respect to y as the Jacobian of u comma v with respect to x comma y. So what is the Jacobian? Jacobian is actually the determinant. So if you have u as a function of xy, v as a function of xy, then I can define the determinant as the Jacobian of uv with respect to xy, and it is denoted by and is denoted by the above uv with respect to x comma y, or simply j equal to uv with respect to xy. So Jacobian is also denoted by j when you have a function of uv, u and v as the function of x and y. So which are the independent variables in this case? Independent variables. And then the other one, dependent variables. So which variables are dependent on some other variable?
U and V.
U and v depends on x and y, and x and y are independent. So independent variables here are x comma y, and dependent variables are u comma v. Okay, so when I have the Jacobian of uv with respect to xy, it is denoted by j, capital J. So that means Jacobian. The Jacobian is also denoted by partial dabba of uv with respect to xy. Why I'm stressing more on this j? Because j dash will be equal to Jacobian of xy with respect to uv. So the difference is now you are going to take the this will be equal to the determinant partial derivative of x with respect to u, partial derivative of x with respect to v, partial derivative of y with respect to u, partial derivative of y with respect to v. So you can see that j and j dash both are a lot different. I mean, in this case, you are taking the derivative with respect to u and v, which are actually the dependent variables. Okay, so but one thing you can quickly identify. What is the one thing? That j dash is actually the reciprocal of j. Okay, so this you can keep in mind. So logically, whatever determinant in this case you will get, the reciprocal has to be this. I mean, if I have j dash, I should be able to get j, and if I have j, I should be able to get j dash without finding those determinants. Okay, fine. Anyways, so there is nothing particular about two variables. The definition can be extended to three variables also. In the same way, in the same way, if u, v, w are functions of x, y, z, as u is equal to phi 1 of xyz, v is equal to phi 2 of xyz, w is equal to phi 3 of xyz. Then j, which is equal to Jacobian of u, v, w with respect to x, y, z will be given by determinant u with respect to x, u with respect to y, u with respect to z, v with respect to x, v with respect to y, v with respect to z, w with respect to x, w with respect to y, w with respect to z. Now my question is, can I define this as ux, vx, wx, uy, vy, wy, sorry, v, yes, uz, vz, wz. Can I say that this is equal to the Jacobian? Yes,
Yes, sir.
yes,
Yes, sir.
because is equal to it.
Transpose.
Determin
Determinant
determinants
A
of,
equals determinant A transpose.
yes, so determinants of transpose are equal, and that's why there is, I mean, nothing particular about this. You can also write that derivatives in columns, and still you will get the correct answer. Okay, so some important remarks here. J dash is defined as Jacobian of xyz with respect to u, v, w. So whatever the order is given to you, if the Jacobian is asked in the opposite manner, I mean the Jacobians are of dependent variables with respect to, sorry, the Jacobians are of independent variables with respect to dependent, then that is J dash. The first and second one, J dot J dash is equal to 1. Okay, so if it is J dash is asked to you, you can simply still find out J and give the reciprocal, and that will be the answer. Okay, so we don't need to worry about these things, okay, which is dependent, which is independent. Whatever you have, you find out the Jacobian and take the inverse of it. Fine. So the example of it given u is equal to x square minus y square and v is equal to 2xy. the above uv with respect to xy is actually the Jacobian of uv with respect to xy. The Jacobian of uv with respect to xy is equal to the determinant of ux, uy, vx, vy. So this is determinant. Derivative of u with respect to x is 2x. Derivative of u with respect to y is minus 2y. V with respect to x is 2y, and v with respect to y is 2x. So this is 4x square plus 4y square. So this is 4 times x square plus y square. Next example, if u is equal to xyz, v is equal to x square plus y square plus z square, and w is equal to x plus y plus z. Then find Jacobian of UVW respect to xyz. So Jacobian of UVW with respect to xyz equal to the determinant ux, uy, uz, vx, vy, vz, wx, wy, wz. This is equal to determinant ux is yz, second one will be xz, third is xy. The second one 2x, 2y, 2z. Third one is 1, 1, 1. So you can actually go on finding the derivative. Sorry, you can actually find out the determinant here by, first of all, you can interchange first and third row by giving minus to the determinant using the properties of determinant. That way you can do, or you can directly go on finding out the determinant. So in this case, what can be done is I will try to use this properties of determinants in this case. So yz is there, in the second one there is xz. So c1 minus c2, comma, third and fourth x is common. Second and third x is common, so c2 minus c3. So we know that addition and subtraction don't change the determinant, and that is why I can do these calculations. So yz minus xz, z common, y minus x. So 2 common, x minus y. 1 minus 1, this term will become 0. Xz minus xy, so x common, z minus y. 2 common, y minus z. 1 minus 1, 0. The third one as it is, xy, 2z, 1. So this is equal to Now from the first column, I can take x minus y common. Common from the second row, x minus y common from the first column, y minus z common from the second column, and what we have in the determinant later is minus z minus x xy 1 1 and in this z. Now it is actually easy. So z into something you will get. So finally it is 2 times x minus y minus z. The third will be x minus z. Fine. Any problem up to this? Example number 3. If x plus y plus z is equal to u, y plus z is equal to u into v, z is equal to uvw. Fine.
Sir, excuse me, sir. Can you please show the previous slide for a moment? Okay, sir. Thank you.
Let me know when you're done.
Yes, sir. I have taken the screenshot. You can continue.
So we look in this, what difference in the previous examples and this, there was exclusively given the required variable. I mean, if I want to find the Jacobian of xyz with respect to uvw, I was having a function of x in terms of uvw. When I was having this kind of case, x is equal to phi 1 of uvw. You don't have it, but you will have to make some proper adjustments in this case in order to get that. So what we will have, x is equal to u minus y plus z. But from the second one, y plus z is uv. So I can write this as u in bracket 1 minus v. Using this, y plus z is equal to uv, I can put that here and I'll get x is equal to u in bracket 1 minus v. Now, since I want to take the derivative, I'll simply write down u minus uv. That would be much better for me to take the derivative. U minus uv. Then y is equal to uv minus z. Now the value of z from the third one is uv minus uvw. This is I have
Excuse me.
told.
So excuse me.
Yes.
So, so could we have found the relation of u, v, and w in terms and respect of x, y, z, and then find the Jacobian dash?
Yes, you can do that. But that is quite difficult in this case. Jacobian of xyz with respect to UVW is equal to determinant xu xv xw yu yv yw zu zv zw. Please do it. You have 5 minutes. I want the answer.
Sir,
Yes.
first row is 1 minus V minus U and 0.
Tell me, I want the final answer, Pratik.
Okay.
Yeah.
U square V.
What is it?
U square V.
Yes.
Final.
Yes, it is correct. Final answer is u square. Next is Jacobians of composite functions. So, which is, I mean, in this, what we are going to see is chain rule for Jacobians. Chain rule for Jacobians. So the rule says that if x and y be the functions of u comma v and u comma v are functions of RNS. R comma s will be better. R comma s. Then, or first of all, that is u x is equal to phi 1 of u comma v, y is equal to phi 2 of u comma v, and later u is equal to psi 1 of r comma s, and v is equal to psi 2 of r comma s. So we can see that these functions can be combined. I mean, all four of them represent one function. So x is the function of uv and uv are the functions of rs. Y is the function of uv, u and v are the functions of rs. So we can see that those are interly, I mean, they are connected in a manner like x, y, uv and UV, I can put the values of R and S. So ultimately, X and Y becomes the functions of a function of R and S. So in this kind of cases where you have composite functions, so what I can do is I can find out the Jacobian here of xy with respect to R S. So what is possible? I can find the Jacobian of xy with respect to the function uv into Jacobian of uv with respect to rs. Okay, so this is the chain rule. Very easy. What you are just doing is you are finding out the two Jacobians now. So xy are in terms of uv. So you find out Jacobian of xy with respect to uv. Then uv are the functions of rs. So you find out the Jacobian of uv with respect to rs. Multiply them. That will give you the Jacobian of xy with respect to rs. Same thing can be done for three variables. So I'll write it down here. Similarly, so if x, y, z are the functions of u, v, w, and u, v, w are the functions of r, s, t, then Jacobian of x, y, z with respect to r, s, t. This is equal to Jacobian of x, y, z with respect to u, v, w into Jacobian of u, v, w with respect to r, s, t. Chain rule for three variables. Number of variables can increase. I mean, there is no condition on number of variables. As I've got for 2, 3, I can get it for 4, 5, 6, whatever number I want. Fine. Let's solve example on this. If u is equal to a into u plus v, x is equal to a into u plus v, y is equal to b into u minus v, where u is equal to r square cos of 2 theta and v is equal to r square sine of 2 theta, a and b being constant. Find Jacobian of xy with respect to r. The Jacobian of xy with respect to r theta will be equal to the Jacobian of xy with respect to uv into the Jacobian of uv with respect to x comma y. So first of all, Jacobian of xy with respect to
Sir,
uv.
upon r comma theta, right? At the last term.
Yes, r comma theta. Xy with respect to uv, xu, xv, yu, yv. So this is determinant. X with respect to u will be simply a. X with respect to v is also a. Y with respect to u, b. And this is minus b. So answer here is going to be minus 2ab. Then the Jacobian of uv with respect to r comma theta. This is determinant ur u theta vr v theta. So ur is 2r cos 2 theta. U theta is minus 2r square sine of 2 theta. Vr is 2r sine theta, sine 2 theta. And v with respect to theta is going to be 2r square cos of 2 theta. So 4r cube will come outside first of all. And then in bracket cos square 2 theta plus sine square 2 theta, that will become 1. Right? So Jacobian of xy with respect to r comma theta, this is going to be minus 2ab into 4r cube, which is equal to minus 8abr cube. Fine. Next example. If u is equal to 2xy, v is equal to x square minus y square, where x is equal to r cos theta, y is equal to r sin theta, find the Jacobian of uv with respect to r theta.
So it is minus r into 2x square plus 2y square.
Minus r into
2x square plus 2y square. Sir, it is 4. 4.
what is x square plus y square? What can you put the values of x and y? X square plus y square will be equal to
So r square
r square. So finally it is
minus 4r cube.
okay. What I have this is 4r cube. Is there anyone who have got 4r cube or it is getting minus 4 only? Fine.
Sir, minus 4 r cube.
Plus 4. Minus 4. Okay. Fine. So maybe minus 4 r cube. Okay. So that is all for today. Before I open the chat box, let me just talk to you about. First of all, how was the midterm? I hope everyone
Paper was good.
paper was good.
Yes, sir, it was good.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Fine. So let me just summarize everything that you have done till now. So in our classroom, tutorials that I have given, there are some theory and one is objective tutorial, right? So the first one was theory. Even the second one was theory. So tutorial 1, Qt, 2, Qt, 3, Qt. Okay, wait. Just stop the recording.